Hey guys, so it is Wednesday. I believe it's Wednesday. Sometimes I forget what day it is because life is weird right now. Algebra 1. We're going to be chewing through our con lessons this week having to do with domain and recognizing functions from graphs and tables. So I'm going to put a timer on the screen, give everyone a few minutes, go make their beds, get a drink. Hey, Lily. And then we'll start chewing through our lessons. So here we go.
I love you too.
I love you too, girl. Claire, I'm in the middle of class. You got to go. Teaching from home. Yeah. I'm in the middle of a lesson. You need to close the door. Let me get a timer on screen. Let's see. It is 12:29, so we got less than 6 minutes. There, that's good. All right, I'll be right back. All right, we're going to give everybody 1 more minute to join us, and if not, we will proceed without them. That's time. Okay. Let's get this rolling. So what we got here are the assignments I pushed out. Various number of people have finished them. So here we go. Let's start with identifying values in the domain. Okay, so with these, what we've got to remember is that the domain, let's get a different color. The domain are our x values. And when we get a function like this over here, there's two main ways that the domain, that it's not going to be part of the domain. So just to explain my thoughts. So what would make something not part of the domain? That's really what we're asking ourselves here. First way, it won't be part of our domain if it's going to be an imaginary number. That's the root of a negative. And B, the other way, it would not be part of our domain if it was undefined. So these are the two things we're going to be on the lookout for. See if this is a good place to put that. Okay, so what makes it part of what would make it not part of the domain? Okay. Well, here's the deal. In this particular equation, x plus 3 would be positive. We just don't want it to be negative. We cannot have that become negative. So how would we make that work? So the square root of negative is bad. So how do we keep it positive? Well, if, and please remember when it says domain, the x, these are our x values over here. These are possible x values. Okay, so if we put these in, the square root of negative 6 plus 3, this would be the square root of negative 3 plus 3. And this one would be the square root of 3 plus 3. So what I did was I put in the x for this x value right here. And what do we get? So this would be the square root of -3. No good. Can't be the root of a negative. That's an imaginary number. This would be the square root of 0. I'm okay with that. That would just be 0. That's fine. And this would be the square root of 6, which is going to be a fraction of decimal, but it's definitely not negative. So these are the right answers. Let's try the next one. Chad, just go ahead and stop me if you need me to. Okay. So what would make this not part of the domain? If the x values right here, these are our x values. If they make something an imaginary or undefined, we're no good. But in this case, if we said 0 minus 3 to the second power, or if we said 3 minus 3 to the second power, or if we said 4 minus 3, I think they're all going to be okay, because this would be -3 squared, which is just 9. That's fine. This would be 0 squared, which is 0, which is fine. This would be 12 squared. Wait, that's a minus sign. Hang on. Back it up. 4 minus 3 is just 1 squared. Which is 1. I think they're all good because none of those are imaginary. None of those are improper. I mean, undefined. So they're all good. Okay, so this one's a fraction. This one, so what we're worried about on this one, because of the fractionness of it, I'm trying to make up words, didn't really come out well. So we want to make sure that we just don't have anything, a 0 in the denominator. This is bad. So as long as we don't have a 0 in the denominator, it should be all right, because here are x values. So this would be -2 plus 3 over -2 plus 2. And that would be 1 over 0. Uh-oh. That's bad. So that is not going to be part of the domain because that's an undefined, goofy thing. You cannot divide things by 0. Okay, so this one would be 0 minus 3 over 0 plus 2. So just -3/2, which is fine. Yeah, no one cares about fractions. It's all good. Last one would be 3 minus 3 over 3 plus 2, which is 0 over 5, which is fine. Because 0 divided by 5 is just equal to 0. That's totally okay. Yeah, getting 0 as an answer is totally fine. Having 0 in the denominator makes things horrible, next to impossible. Last one for this lesson. So again, we don't want, so what's bad here The square root of a negative value is bad. We just don't want that to happen. So this one would be the square root of -2 times -2, which is the square root of 4, because negative times negative is positive. That's fine. This one's the square root of -2 times 2, which is the square root of -4. Uh-oh. That's no good. This one's fine. This one's not. Last one, square root of -2 times 4. That's either the square root of -8. Yeah, that's no bueno. No good there. The only one that had the positive of a root, I mean a root of a positive value was the first one. Okay. So that is determining the domain of a function. The next one, wait, which one did I just do? That was identifying. Okay. So the next one's determining domains of functions. Okay, so this is like a step above what we were just doing. So I need to keep some of this on screen. So this is the same as the last lesson, except they're requiring that you sort of do some of the thinking. So they gave us this equation up here, this function, g of x equals the root of x plus 3. And they're saying, what is the domain of g? So how do we make sure, for this particular problem, how do we make sure that this is not gonna have any problems? We know, okay, so I guess the question is, how would we end up making this bad? So if having a negative root if having the root of a negative is the bad thing, we don't want that to happen. Well, as long as x is, like if x was -3, right? If we just put in a -3 for x, it would come to square root of 0, which is fine. So as long as x is -3 or bigger, I think we're okay. It's if it gets smaller than -3, that's where there's an issue. So I think there's the x would have to be greater than or equal to -3. Right. Okay. That's good. So here's our next question. Now we got to make sure we're not turning things imaginary or making things undefined. Thing is here though, this isn't a fraction per se. There's nothing in the denominator, and it isn't a square root of any measure. So I'm pretty sure it'll just be all real numbers. See if I'm wrong. No, I'm good. Okay, so this one's a fraction. So as soon as I see a fraction, I'm worried about having an imaginary number. So the goal here is to make sure that we don't end up with a 0 in the denominator, because that's bad. So, okay, if we've got x plus 3 or x plus 2, What can x not be? X cannot be, so x cannot be equal to -2. Because if you put a -2 in there, that would make the denominator 0. I think that's it. X cannot be -2. It can be anything else. I don't care if the fraction is negative or positive. It just cannot have a 0 in the denominator. And the only way that becomes 0 is if you add a -2 to the 2. Yeah. Okay. Last one. All right, let's just remember that the root of a negative anything is bad. So what do we got here? We got the root of -2x. Okay, well, if we're multiplying, okay, so if x is 0, we'll be okay, because 0 times -2x, just make that 0. And the square root of 0 is fine. Not undefined or anything, or imaginary. The problem is x cannot be a positive number. You see, because of our integer rules, we've got to have a positive value underneath the radical, and the only way to get -2 to turn into a positive number is to multiply by another negative number. So x is going to have to be negative or 0. So negative works and 0 works. So where is that? So that could be 0 or less. 0 or less. Less than, I guess that's it. So x has to be less than or equal to 0, because if it's a negative number, it'd multiply and make positive. And if it was 0, that's fine. Square root of 0, I'm totally okay with. Yep, there it is. Okay. That completes this lesson. These word problems were a little tricky. I had to get used to them. Okay, so the first thing it mentions, Tanya walked for 17 minutes from her home to a friend that lives 1.5 kilometers away. Okay, so d of t is Tanya's remaining distance to walk in kilometers. Okay, so as soon as it mentions time, I'm going to do real numbers, because time is always running. The domain is the x values. So let's see. Distance is the y, time is the x values. So I guess it'd be 0 to 17. Cool. So the whole gist of this lesson here, let me zoom out. With this lesson, you really have to identify which value is the x, your domain, which value is the y, your range, and really critically think accordingly. It's like this next one. The house numbers on certain street go from 1 to 88. Function b of n models the type of the building whose number is n. Okay. So the building depends on the number. So n is the domain. N is the domain and b is the range. So n house numbers go from 1 to 88. So those are integers. They're whole numbers. They're not going to be in between these. And that would go from 1 to 88. So, yeah, okay. Aiden is a spice trader. He sells an amount of cumin seeds from 1 kilogram to 1,000 kilograms. He charges $5 for 1 kilogram and $2,000 for 1,000 kilograms. the weight. The price depends on the weight. So the W is the domain. The weight is the domain. Okay. So I'm sure that it's going to be from 1 to 1,000. Like that's the weight. The question is, will we do this in integers or real numbers? I could argue it both ways. Because it says he sells from 1 kilogram to 1,000 kilograms. So the question is, would Aiden here sell 576.5 kilograms? Like, would he go that specific, or does he only sell it in 1 kilogram, 2 kilogram, 10 kilogram amounts? I'm going to go with real numbers. My hunch is here that he's going to be able to sell this in less than or more than just whole kilograms. We'll see if I'm right or wrong. I might be wrong, but we'll see. No, it took it. Cool. Yeah, I figured if they were pouring cumin seeds, they weren't going to measure it off that exactly. Last one. R depends on M. Models the average monthly rainfall in Tanzania. Okay. So the rain depends on the month. Okay, so if the amount of rain depends on the month, that means the month is the domain. The domain would be integers because it just goes from January to February. That's 1 to 12. Again, it's the hardest part about this is just understanding which one of these elements is the domain, and then how deep and wide is the domain. That's all it is. So done with that lesson. And now for the super fast stuff. Okay, so when you got a graph, so here's the rule. There's the rule. Each x value is only supposed to get a single y value. So if we grab this vertical line and we swipe it across, you see how the blue line is touching it twice? So this is not a function. See now this one, as I move my line, it's only ever touching the blue line in one spot. So that means that it is a function. So this one, do any of these dots line up with one another? Nope. None of them line up with each other. So this is a function. They passed the test. Last one. Oh, tricky one. So it's a vertical line. That means all of its dots are above each other. So they're all sharing an x value, and that's not allowed to be a function. So that is not a function. That's the vertical line test for you. Nice and easy. All right, last one. Here we go. Okay, so do we have any x values that repeat? Let's see, the height of tables. And okay. Can the height of the chairs be represented as a function of the, okay. 75, 74, 76. Okay, hang on. I got a 75 here and a 75 here. 76 here, 76 here, 74, 72, 77. Okay, so here's the question. This 76 goes to a 47. This 76 goes to a 47. Okay. This 75 goes to a 46, and this 75 goes to a 46. So yeah, so we have multiple x values, but they go to the exact same point. So we're gonna say these are okay. So let me make an addendum to that rule I just said. Okay. Then they call. Yeah. Okay, so that's the rule. And these all check out because, yeah, they do use x values, domain values more than once, but they go to the exact same numbers. So it is a function. All right, do any of these repeat? Can a teacher's hobby be represented as a function of the subject the teacher teaches? All right, let's check for duplicates. So, okay, so I've got an English teacher here and an English teacher here. One history, I got two math. So physics, Spanish, gym, and history are all unique. Okay, so English goes to wave surfing. English goes to wave surfing, so they're okay because they went to the exact same output. Math goes to rock climbing. Math goes to rock climbing. They both go to the same thing again, so they're okay. $20, $25, $18, $22, $30, $20. 22, 23. So our unique domain values are 25, 18, 30, and 23. So now the question. So 20 goes to 40, and 20 goes to 42. Uh-oh, that's not good. 22 goes to 42, and 22 goes to 41. Oh, not good. Nope, this one's not a function because these two are not the same, and these two are not the same. So nope. You're not allowed to double up on domain values unless they go to the exact same thing. All right, I believe this is the last one for the day unless chat or email explodes with questions. 150, 220, 370. Okay, can the actual attendance be represented as a function of the planned attendance? Okay, so 150, 220, 370, 290, 300, 220. So 220 there, and 220 there. 150, 370, 290, 300, and 200. Okay. So now these, we're only allowed to double up on x values if they go to the same thing. So 220 goes to 200, 220 goes to 200. I think that means it is a function. Okay. Well, I've just done all of your homework assignments for you. I hope that this has been of some use to those of you watching on the replay. And, I got a couple of announcements. So the middle school is going to be collecting Chromebooks next week. So please be ready to go over to the building and turn yours back in with its charger and its bag and everything. That'll probably also give you an opportunity to pick up any belongings you left in your locker, because those have been cleaned out for you. Trash thrown away, but collectibles and things are for you. Let's see what else. Oh, lunch money. If you owe the lunch money to the lunchroom, you got to get on that. They are going to get left with the bill, and that's not fair to them. So until next time, make your beds, take care of yourselves and your family. I'll see you guys later.